This takes me to the last paper of this day, the second day of the 7th CIRPe Global Web Conference. We have a value stream oriented paper here with which we want to conclude the day. It is entitled Multidimensional Assessment of Value Stream Design Alternatives. It comes from a lab in Darmstadt, Germany, and the authors are Urnauer, Joscha Kaiser, Matthias Gunkel, and Joachim Metternich, who leads the group in Darmstadt. Please.
Hello, everybody. I would like to welcome you at my session on our paper with the title Multidimensional Assessment of Value Stream Design Alternatives. My name is Joscha Kaiser. I'm a researcher at the Technical University in Darmstadt at the Institute of Production Management, Technology and Machine Tools. In the next minutes, I will give you an overview about our research and the scope of this paper. Afterwards, I will show you the motivation for what we've done here. The motivation results in an analysis of existing key performance indicators for value streams and existing assessment methods concerning production systems. Based on our literary review, we give a recommendation on how to assess different future state maps in value stream design. And last but not least, I will give you some first practical findings on an example. What is value stream design? Value stream design is a part of the value stream method that is a very heuristic procedure that you can apply on basically any production system. It gives you an ideal future state for your value stream that you want to design, considering basic lean principles such as a takt system, flow, pull systems, and a very clear and transparent production control. The result of a value stream design is a future state map where you can see the supplier information and material flow, where you have your customer or client information and material flow, where you can see your own material flow inside your production system or your factory in your value stream. You have your production planning and control, so your internal information. And after all, you have a total product cycle time or throughput time. A big strength of the value stream method, and therefore also for the value stream design, is that it's very widely used in industry, that it has become a standard approach in lean production and logistics, and that you can use it in very different production systems. So it's a very standard approach in practice that is still growing in popularity. And that is why we are working right now on the method for simulation-based value stream optimization. So we are looking at the value stream analysis as well as the value stream design, and we are selecting simulation methods to simulate and quantify the best design options that we can get in our different design alternatives within the value stream design process. The aim of this paper would be to show you the valuation of different future state alternatives and how you can choose the best one out of different alternatives. When I'm talking about value streams, I'm talking about in-house value streams in forms of a serial production or logistics of the discrete part industry. And we assume that a product family oriented product segmentation to the lean principle with respect to product characteristics and customer demand has been done in advance. So we are not talking about a job floor production or anything like this. We also have to assume that processing time, cycle times, and operation times of our processes within our production systems have to be known, or at least to be reasonably estimated for our new value stream design. The existing research gap that I want to talk about here is something that I could also see a lot from my practical experiences, is that under some circumstances there might be more than one suitable alternative in the planning process in value stream design. And that the process of value stream design is highly dependent on the experiences of our value stream design team. This might be, for example, the case for the pacemaker positioning problem within our value streams, something that could be seen in literature as well. That might be true for different process integrations, also for different transport forms between our processes in our value stream. So there's a number of possible planning alternatives that have to be considered and that have to be assessed if they are promising. For the review of assessment methods, a forward and backward search was carried out starting from 3 popular value stream method books using different terms and databases as stated within our paper. With regard to a holistic value stream evaluation, only system-related key figures are considered. We used the categories flexibility, cost efficiency, and flow to categorize the identified KPI in the analyzed value stream method literature. Using Harvey balls, a full ball signalizes that the KPI is explicitly defined in the publication. A half ball stands for an implicit mentioning, and the white ball means that the KPI is not considered in the respective publication. Looking at flexibility in literature, flexibility KPIs relieve quite little consideration. Nevertheless, every part, every interval, the ePI KPI is the major figure to measure flexibility in a lean production system. Looking at costs, the figure also includes 2 papers on lean accounting, which is a cost calculation approach to assess value streams. However, no publication is found that only deals explicitly with costs in value stream. Though costs play an important role in the articles on assessment methods, none of the cost-related KPIs is dominant among the analyzed methods. Looking at flow, the throughput time of a production system can be approximated by the work in process and the customer tag, according to Little's law, since the sum of process time is typically much lower than the range of the work in process inventories. Throughput time is the most used KPI in the identified approaches. The degree of flow is calculated by dividing the sum of processing time by the throughput time. This ratio gives information on the time share that is spent on value-adding processes. The KPI that is most frequently used in assessment methods to consider timeliness towards a customer is delivery reliability. The definition for on-time delivery is varying a lot in literature and should be adapted according to your use case. To summarize, it is evident that the different KPIs do not only correlate within the defined categories, but also across them. This means, for example, that a high work in process inventory may improve the delivery reliability of your system, but at the same time it increases the capital commitment costs and the throughput times. It is the challenge of a good value stream design to find a suitable compromise between these dilemmas and to choose the different between the different alternatives that you have. After all, a key figure system should not only contain a manageable amount of KPIs and their calculation and data acquisition, effort should be well balanced with respect to their benefit. This also means that practitioners must be aware of the interdependencies between the different KPIs so that the selected KPIs do not overlap too much in their information value. Taking into account all the assessment methods in literature, multi-criteria decision problems have in common that multiple and partly conflicting objectives with different units have to be pursued. They are classified into 2 categories, the multi-objective decision-making and the multi-attribute decision-making problems. This paper only focuses on multi-attribute decision problems, as we have a finite set of alternatives that we are looking at in our future state map. A universal method must include costs as well as non-monetary KPI and must be able to handle KPI with very different dimensions. That is why many of the presented approaches as the utility analysis or the cost time profiles cannot be recommended to universally assess value stream designs. We have some criteria given by our value stream design, with is, for example, the simplicity, handling of different dimensions with individual layers, and the stability of our solutions. And that way we've chosen TOPSIS as our first choice. To summarize the requirements of a structured value stream design assessment, we were looking that we have to consider cost as well as non-cost utility figures within individual rating. We have to be able to handle KPIs with different dimensions, and we have to have an assessment approach that is very easy to generally apply without any expert knowledge within our value stream method. So that's why we've chosen TOPSIS, which is the technique for order preferences by similarity to ideal solution. To use TOPSIS, you use it in 6 steps. First, you normalize your different KPI. So afterwards, you do your weighting, or your planner does your weighting, which is the only subjective influence that you have in your overall system, but maybe the most crucial part of the whole procedure. After this, you, with your set on innovation, you define an ideal positive or negative solution with all the parameters given. After this, in step 4, you calculate a distance between the ideal solution and your real value stream design alternatives. And in the end, with this similarity measure, you rank the different alternatives, and the one that has the highest ranked alternative is the one that you choose. The presented approach has been used to establish a new value stream for pneumatic cylinders at the Center for Industrial Productivity at the Technical University in Darmstadt. One major goal of the new value stream design that we've implemented was to integrate a production process for prioritized customer individual products. So the figure illustrates a future state map for direct shipping with the pacemaker positioned at the bottleneck, and a future state map for shipping from a finished goods storage. The custom process and the assembly can either be linked via a direct transport, for example by using an automated guided vehicle, or by integrating the transport into an existing milk run system that we have in our production facility. Further design alternatives are possible in this example. To show the functionality of TOPSIS to you, only the resulting 4 alternatives are used. In the following, they are named according to the shown table. To find our best value stream design alternative, we've chosen the following KPI for this example. It is firstly the capital commitment cost, the degree of flow, and we also considered the order lead time for customer individual products, because this was quite important for this production project. Based on a discrete event simulation, in this case it was a plant simulation, we were able to determine the degree of flow and the order lead time of individual orders that we want to take into account. So in this example, the alternative 3 turns out to be the best solution, resulting from the very short order lead times with our automated guided vehicle that we use for the direct transport, the very high degree of flow, and the relatively low capital commitment cost that we need for this production alternative. I'll show you some other example where you can apply the assessment or TOPSIS assessment. This is an example that we are doing right now in industry with very different value stream alternatives. In the last slide, I've shown you an example with alternatives considering the transport design and different shipping principles. Within this example, you see different pacemaker positions or different process integrations that are possible. So yeah, focused on this example, we've chosen very different KPI. And yeah, we hope to find very good results with this procedure in practice as well. Okay, so I'd like to thank you for your attendance, and I'm quite keen on your questions.
Thank you, Joscha Kaiser, for doing this presentation. and for presenting your results from the research from a DFG project. We're now taking the tour to have him live here for the question and answer session. Okay. I'm just told that we have to wait for some seconds more until we have that Skype call ready. So in the meantime, just let me show that. If you comment, do that. Have a look at LinkedIn. We're going to post some more photos, and then do that. We're going to post some more photos on that live. So it seems like we have now Joscha Kaiser live.
Hello, Mr. Freddy.
Hello, Joscha Kaiser. Thanks. Very good to have you here. Now we hope we don't have technical problems anymore. So that can you understand us?
Yes, I do. Yeah.
Thank you. So that's very good. Thank you for the presentation and the paper. We are really delighted to see that DFG project results in our conference right next beside all the others that have been more directed towards practical issues. Thanks for that. The first question that I'd like to address is about the demonstration of the concept that you have. I know that in Darmstadt you're really good at doing really good with the demonstration manufacturing plant. So I hope that you do the demonstration there, and I'm really keen to learn about that more.
Yeah, I mean, thank you for the question. What we're doing is we have our process learning factory, or real factory, where we are implementing projects like this. And our main aim in this project was to combine simulation and the value stream method, and to get strength of both methods and to combine them in one. As Professor Schmidt stated earlier, you have strength and weaknesses in the value stream method, and we want to give a simulation oriented approach to get out of those weaknesses of the value stream method.
Okay, can you tell us a bit more about what you wanted to how you want to design the case studies on which you demonstrate that in your process learning facility?
All right. We have different states that we have in our production. We are producing a pneumatic cylinder, which is our value stream that we're dealing with. And now we can combine different value streams, or can try out different value streams in practical implementations within our factory. And that was part of this research as well, because we could assess different value stream options with our methods that I presented earlier.
Thank you. So can you just mentioned the value stream oriented method and the simulation based method. Can you comment on the complexity and the suitability of these methods that you have encountered in your examples?
Yeah, so we have different things that we have to encounter. For example, a value stream method, as we've heard earlier, it's quite difficult to use it in a production area or in a value stream with a high variety of tucked spreads and a high variety of products or of variations in our product. And we have the expert knowledge that we need for simulation, and we try to eliminate this by taking the strength of both. So we try to have a method that does not only work for a very simple value stream with only one product, but also for more complex production systems. But it's always our aim to keep the simplicity of the overall approach, because that's why it's so popular in industry, the whole concept of the value stream design that we're doing.
Do you reckon that when you achieve that you can implement that into industrial practice, like to have the combination of both these methods, that it remains as simple as it is right now, so that they just still can cope with the complexity that they will have there?
Well, to be honest, what is still very difficult is to get the right simulation model, and you can't still get rid of the expert knowledge that you need for the simulation model. But we've tried our method not only at our learning factory, but also in a whiteboard production, like the whiteboards that you had in offices, with a lot more variety in the production field. And also in the electric switch cabinet production, so with higher takt spreads and so on. Okay. And we have some quite good results to show the different alternatives, and to choose the best one in the end.
Okay, so thank you for sharing these details with us, and for joining this call, and for taking the effort to do this contribution, and for doing the commenting. Thank you very much.
Thank you very much. See you soon. Bye-bye.
Goodbye. So this was the end of the presentation of the paper, which is entitled Multidimensional Assessment of Value Stream Design Alternatives. It is authored by Urnauer, Joscha Kaiser, who we just spoke to in the question and answering, Matthias Gunkel, and Joachim Metternich.